All right, welcome. Today we're going to be looking at Quiz 5.1 review, and the quiz is going to go over lessons 5.1 and 5.2. So lesson 5.1 covers congruent figures, and lesson 5.2 covers congruent triangles. So we're going to do some examples here. I'm looking at this problem. It says use the following to answer these two questions here. We're going to use triangle CAB, which is congruent to triangle DET. Now, since this is given and these two triangles are congruent, we can apply something called CPCTC, which stands for corresponding parts of congruent triangles are congruent. So, since these two triangles are congruent, then we can say that the corresponding parts of the two triangles are congruent. For instance, since C is the first letter of this triangle, then it's congruent to the first letter of the other triangle. So C and D are congruent by CPCTC. A is congruent to E, B is congruent to T, and I'm talking about angles, by the way. So this is angle C, angle A, angle B, angle D, angle E, and angle T. And then we can also talk about line segments. Since C and A are the first two letters, line segment CA must be congruent to the first two letters of this triangle. So that would be line segment DE. Line segment AB is congruent to line segment ET because these are the last two letters and these are the last two letters. Here's the first and the third. So line segment CB must be congruent to line segment DT. And again, I'm just using CPCTC. So here we go. We're going to use the given statement here. This is a congruent statement, by the way. Angle B, this is angle B of this triangle. It's the third letter. Therefore, it's congruent to angle T. Again, by CPCTC. Line segment CB, here's the first and the third. It's congruent to line segment DT. All right, so I'm going to go ahead and move on here. It says, use the figure to the right. Triangle LMN is congruent to triangle QRS. So here's the thing. This is our given statement. You can assume that these two triangles are congruent because it states right there, this congruent symbol just says it all. And the fact that these two triangles are congruent, then we know that we can apply CPCTC to answer certain problems here. I need to find the value of X, I need to find the value of Y. So here is triangle LMN, and this is triangle QRS. So I can see that since I'm trying to find X here, this is where X is located. It's part of that 2X plus 11. I know it's really hard to see because it's dark here, but 2X plus 11 is part of LM. So if I'm looking at line segment LM, it's the first two letters of this statement here. So since this is the first two letters, I need to look at the first two letters of the other triangle, which is QR. So line segment LM corresponds with line segment QR. And that's great because, look, we have our 3x minus 9. And those two things, those two side lengths, have those x's. So I can say that LM is equal to QR, and LM is 2x plus 11, which is equal to QR, which is 3x minus 9. Then I'm going to go ahead and apply algebra. So I should get 20 equals x. So x is equal to 20. So now what I'm going to do is I'm going to go ahead and find y. So y is right here, that y plus 10, and it's part of angle M. And here's my y for this triangle, and it's part of angle R. So I'm going to write this. So here's angle M. So the measure of angle M is the second letter, so it corresponds with R. So the measure of angle M is equal to the measure of angle R. So the measure of angle M is y plus 10, which is equal to the measure of angle R, which is 2y minus 40. So I'm going to go ahead and use my algebra skills here. So then I get 50 equals y. So x is 20 and y is 50. So if you can't see this, so the measure of LM is 2x plus 11. The measure of angle M is y plus 10. The measure of angle R is 2y minus 40. And the measure of RQ is 3x minus 9. Okay? All right, let's go ahead and move on here. We got number 19. It says triangle ABC is congruent to triangle DEF. And the measure of AB is 7. The measure of BC is 9. The measure of AC is 11 plus x. And the measure of DF is 3x minus 13. And lastly, the measure of DE is 2y minus 5. So what I'm going to do, I know that these two triangles are congruent, so you know I'm going to apply CPCTC. I'm going to draw a triangle ABC. So A, B, C. So I'm going to start up top and then go clockwise when I'm writing my or drawing my figure and labeling it. So triangle A, B, C. And then here's triangle D. So it's going to go up top like the A is. And then it's going to be E here, F there. So we have AB, which is 7. BC, which is 9. AC is 11 plus x. DF, which is right here, 3x minus 13. And DE is 2y minus 5. So I'm going to go ahead and find the value of x. So I see an x here, x there. So 11 plus x is part of AC. So AC is the first and the last letters. So I should look at the first and the last letters of this triangle, which is DF. So it's right there. So you know for sure that they correspond to each other and they are congruent by CPCTC. So I can say that AC is equal to DF. So I have 11 plus x, which is equal to 3x minus 13. I'm going to subtract both sides by x here. So I have 11 equals 2x minus 13. Add both sides by 13. I know you can't see that, but here we go. So you get 23 equals 2x. Let me see if I made any mistakes here. So 11 plus x equals 3x minus 13, right? And then I'm going to subtract both sides by x. So I get 11 equals 2x minus 13. Add both sides by 13. This should be 24, not 23. So then now I'm going to divide, so x equals 12. So that is the value of x. Now I'm going to go ahead and find the value of y. So this expression carries my y, and it's part of DE. So looking at DE, it's the first two letters of this triangle, and it corresponds with the first two letters of this triangle. So it's AB. So DE equals AB. The measure of DE is 2y minus 5, which is equal to AB, which is 7. So go ahead and add both sides by 5 here. You have 2y equals 7 plus 5, which is 12. And then divide y equals 6. So there you go. You have y equals 6. So x equals 12, y is equal to 6. If I'm going too fast, make sure that you pause, rewind, so that you're able to get caught up with the review. Okay, so now I'm going to go ahead and flip the page, and we're going to get into the territory of 5.2. So with 5.2, remember we talked about these postulate/theorems. We talked about side, side, side. We talked about side, angle, side, angle, side, angle, and angle, angle, side. So I'm going to look at number 4 here. So this is how I'm going to approach this. I notice that these two sides here are congruent based on the number of tick marks. It has 2 here, 2 there. And I'm going to look at these two sides here because they have 3 tick marks. So these two segments or these two sides here are congruent to each other. And then lastly, because these two triangles share this same side here, this is using the reflexive property. So I can go ahead and mark or highlight that. Okay, so since these two side lengths correspond and they're congruent to each other, I'm going to give them a little s. And since these two side lengths correspond and are congruent to each other, they get a little s. And since they share the same side, therefore, they're congruent, they get a little s. And by the way, when they share the same side, it means we're using the reflexive property. Okay? Our goal here is to prove whether or not these two triangles are congruent. And we use these shortcut theorems to do so. So, by looking at this, I'm going to start with this yellow of this triangle here. So I'm going to go yellow, green, blue. So it's side, side, side. And I need to do the same direction, but looking at this triangle here. So it's yellow, green, blue. So it's side, side, side. So these two triangles are congruent by the side, side, side theorem. And we need to write a congruent statement. Since these two triangles are congruent to each other, I need to write a congruent statement. And luckily for us, the left-hand side is already written for us. All we need to do is fill in the right-hand side. We need to look at, when we're writing this stuff, we need to make sure that they are written in order of correspondence. So A is first. We're looking at this triangle, by the way. So A is first. So A is between the yellow and the green. So that means I need to find the vertex that's between the yellow and the green. So it's going to be D. D is going to be the first letter. So A corresponds with D. B is between the green and the blue. So that means that I need to find the vertex of the other triangle that's between the green and the blue, which in this case is going to be C. And then C is between the blue and the green. So I'm going to put B because it's between the blue and the green. So triangle ABC is congruent to triangle DCB. So DCB. Number 8. Okay, so one thing that we need to note is this. We have these little arrows here. And these arrows indicate we have parallel lines. And when you have parallel lines, that means that we have Parallel lines cut by a transversal, therefore we have the alternate interior angles. It has to look like a Z in order for us to mark those two angles there. Okay, so let's go ahead and note this as well. We have our reflexive property. They share the same side. We have one tick mark for this side length and that side length. That means we need to use two tick marks this time. And then I'm going to go ahead and start highlighting. We know that this side length must be congruent to this side length. So I'm going to give them a little S here and an S there. We know that this angle here is congruent to that angle. So we're going to give them a little A here and a little A there. And then lastly, we have that reflexive property. So we're going to give this an S and that an S. So I'm going to go green, that's yellow by the way, I know it's hard to tell. Green, yellow, blue, side, angle, side. And then I'm going to look at this triangle using the same direction. Green, yellow, blue, side, angle, side. So these two triangles are congruent by the side, angle, side postulate. And we can definitely say that these two triangles are congruent by the side, angle, side postulate because here's our included angle. Included means that it's between the two objects. This angle is included because it's between the two sides. So side, angle, side proves that these two triangles are congruent, and since these two triangles are congruent, we can write a statement. Triangle XWZ is congruent to triangle what? Triangle XWZ is the triangle up top here, so I need to write our triangle for the right-hand side of the congruent symbol. So X is located right here. It's the angle, so it corresponds with this angle here. Z goes first. W is right here, corresponds with Y. And then lastly, Z is right here. It corresponds with X. So triangle XWZ is congruent to triangle ZYX. Number 7. Now you're going to be given something like this, and you're going to use your picture to mark anything else. So you're going to use the given to mark your picture, and then you're going to note anything else that, is part of the picture that's not stated here, if that makes sense. So it says, given that line segment JM bisects angle KJL, this is line segment JM, and it's going to bisect angle KJL, so it's referring to this angle over here. And what this does, it's going to split this angle into two congruent parts. So it's very, very important that you understand that what we're dealing with here is an angle bisector. It's going to split this angle into two congruent parts. Note that, oh, look, we have this 90-degree angle. It's on the same line here. So therefore, this angle here has to be 90. So it can form that linear pair. It adds up to 180 degrees. And then lastly, these two triangles share the same side. So let's go ahead and mark this angle is congruent to that angle. So they get a little A. This side is congruent to itself, right? Because these two triangles share that same side. So they get a little S here and a little S there. And here's our 90-degree angle. There's our 90-degree angle there as well. So they get a little A for angle. So looking at this triangle, I go yellow, blue, green. So it's ASA. And I need to do the same thing with the other triangle, yellow, blue, green. So it's ASA. So these two triangles are congruent by angle, side, angle. And my statement, here's triangle KJM, KJM. K is going to correspond with L. J is going to correspond with J because, they're both yellow. And then M is just M because they're both green. So since these two triangles are congruent by angle, side, angle, then our congruent statement should be triangle KJM is congruent to triangle LJM. Number 2. All right, so this one's pretty straightforward. We can mark stuff. This angle is congruent to that angle. So I'm going to write A. This side length corresponds with that side length, and they're congruent because they have the number, or I should say that they have the same number of tick marks here. This gets a S here and an S here. And then this angle and this angle correspond and are congruent. So what do we have? We have ASA. So I'm starting with green, then yellow, then blue. And I have to follow that same direction with the other triangle. Green, yellow, blue. Angle, side, angle. So then we can write our statement here because these two triangles are congruent. We have triangle LMP. So L, it's blue. It's going to correspond with Q. It's also blue. M, there's no color here, but we know for sure they correspond with S. And then P corresponds with T. So triangle LMP is congruent to triangle QST. All right, so now what I'm going to do is I'm going to flip the page. We're going to do some more examples. All right, here we go. Given that W is the midpoint of line segment XZ and line segment XY is congruent to line segment ZY, are these two triangles congruent? Notice that it says W is the midpoint of segment XZ. Here is W, and this is line segment XZ. If you have a midpoint, it's going to split this whole segment into two congruent parts. So then we're going to go ahead and mark that down, which we already did, so I can check this off. Note that line segment XY is congruent to line segment ZY. So here's XY, and this is ZY. So I can go ahead and just say, oh, these two segments are congruent, and we're going to give them 2 tick marks each. And since these two triangles share that same side because of the reflexive property, then we've already used 1, we've already used 2, now we got to use 3. So then, okay, well, we know that this side correspond with that side, and they're congruent to each other. So they get a little S. We have these two side lengths, which are congruent to each other. They get a little S. And lastly, because of the reflexive property, those two sides are congruent. So we can just safely say that those two triangles are congruent by the side, side, side postulate. And since they are congruent, we can write our statement here. So triangle XYW, here's XYW. We have a yellow, yes. So X corresponds with Z. Y is going to correspond with, so let's see. So X corresponds with Z. So triangle XYW. So then this is going to be ZYW. Okay. Number 15, line segment AE bisects line segment BD, and line segment AB is parallel to line segment DE. So line segment AE is going to bisect line segment BD. Remember, bisecting means it's going to split an object into two congruent parts. Since this is going to bisect BD, it's going to create a midpoint. This is what we call a segment bisector. If an object bisects a segment, then that object in particular is what we call a segment bisector. And when you have a segment bisector, it creates a midpoint. And when you have a midpoint, well, it's going to split this segment, in particular line segment BD, into two congruent parts. And notice that line segment AB is parallel to line segment DE. So I'm going to draw my little arrows here, and it should look like a Z, because when you have parallel lines cut by this transversal, yes, then we have the alternate interior angles. We have the alternate interior angles. And then lastly, we have this. We have vertical angles involved. So these angles are congruent. So now I'm going to go ahead and just highlight and write some stuff down. We have one arc. We have one arc. We have one tick mark. One tick mark. And then we have the two arcs here, two arcs there. So I can write A for the greens. We have S for the yellows. And we have A for the blues. So we have an angle side angle situation. So triangle ABC is congruent to triangle. So A corresponds with E, B corresponds with D, and C corresponds with itself. And that's all for that problem. Now, we can't forget about the angle side postulate. This example here deals with the angle side postulate. So what we're going to do is we're going to do the same thing as we've been doing. We're going to start highlighting stuff and labeling stuff. So I notice that this angle corresponds with this angle because they're both 90 degrees. So they get a little A. And this side corresponds with this side, and they're both congruent because they have, the same number of tick marks here. They have one each. So they get a little S here and an S there for side. And then we have the vertical angles. So those two angles are congruent. So they get an A here and there. And we say that these two triangles are congruent by the angle side postulate because notice that, these two angles are on the same segment. So I have angle, and then there's my non-included side. So the side is going to be, next to the segment that has those two angles. So it's going to be read as angle. Again, they're on the same segment. Then you have side. Since I started yellow and then green to blue, I have to follow that same pattern when looking at this other triangle. Yellow, green, blue. Angle, side. So notice that the two angles here are on the same segment. So it's angle, side. So these two triangles are congruent by the angle side postulate. And then writing a statement, I'll let you figure that out, or you can look at the notes video. All right, so to wrap everything up, please make sure that even though you watch the video to review for the quiz, I highly encourage that you look over your 5.1 and 5.2 notes and homework assignments so that you are better prepared for this quiz.